Okay, so now we've talked about the partial fraction decomposition, and it's kind of a pain. It's doable, but it's not particularly pleasant. Um, but the good news is that there's a shortcut. And this shortcut is known as the Heaviside cover-up. Now, typically, when we think about a cover-up, we think about something where somebody tries to hide something nasty, and to keep other people from having to see it or getting to see it. And generally, like in political scandals, etc., cover up is a bad thing. Here, you would prefer not have to see the nastiness of all of this partial fraction decomposition, and the Heaviside cover up is a process by which we can allow ourselves to not have to deal with that. So I'm going to start here with a fraction that's already factored. I could have started with this thing all multiplied out and then shown you how to find the roots, etc., by doing synthetic division, but I've already done one like that, so I'm just going to do it like this. Now this tells us that this would be a over x minus 1 plus b over x minus 2 plus c over x minus 3. That's where this came from. Alright, and then I would tell you need to multiply through by x minus 2 and x minus 3 for a, x minus 1 and x minus 3 for b, and x minus 1 and x minus 2 for c. And then you'd have a whole bunch of terms, and you'd have x squared terms, and you'd have x terms, and you would have constant terms, and you'd have 3 equations and 3 unknowns, and you'd have to solve that. And that's kind of a pain. But the Heaviside cover-up says we're going to do something a little bit different. Here's what we're going to do. We're going to take this whole thing and multiply times x minus 1. Okay? Only. And when I do that, what happens here? Well, this side, the x minus 1 on the bottom will just cancel this x minus 1, so I'll have this. Over here, I'll just have a plus b times x minus 1 over x minus 2 plus c times x minus 1 over x minus 3. Now, once I have done that, because x minus 1 is the thing that I multiplied by, I'm going to let x equals 1, the thing that would make that 0. And when I do that, what happens is that term and that term both go away, because 1 minus 1 is 0. Those terms will go away, which is why it's called a cover-up, because you can just basically cover those up like that. And you say, okay, so then all I have over here is a, and I let x be 1. I get 2 on the top, I get minus 1 and minus 2 on the bottom, 1 minus 2 and 1 minus 1, and that tells me that a is 2 over 2, which is just 1. And I determined a that quickly. Similarly, and I don't necessarily have to write it out every time because I know exactly what's going to happen. By multiplying by x minus 1, the x minus 1 here is going to go away, so I can ignore it. A is going to be by itself, and those terms are going to go away. So I'm going to kind of approach it that way. For the next one, I'm going to say, while I'm dealing with x minus 2, what's going to happen? Well, I'm going to let x be 2. I look at this equation right here and I say, I let x be 2 except for right there. That one's going to be canceled out. And so when x is 2, I've got 2 squared plus 1 over 1. That's not going to be there because the x minus 2 is going to cancel it. This is going to be negative 2. And on the right-hand side, a and c are going to go away, and it's just going to be b. And that very quickly tells me b is negative 5 over 2. And I can do the same for c, where I'm dealing with x minus 3, means I'm going to let x equals 3. Again, I look here and I say I'm going to let that happen here. That's going to be 9 plus 1 in the numerator. 3 here gives me 2. 3 here gives me 1. And this one's not going to be there. And these are both going to be covered up, and I'm just going to have that equaling c. And that looks a lot like 10 over 2, and c is going to be 5. So that's the Heaviside cover-up. And that works. It's a nice approach to doing this, which allows us to break it into its reduced, or its previous fractions, do the process without having to go through all of the pain of getting the common denominator.